Today I'm going to talk about maximizing volume, getting as much stuff into a container that you can. Here is a summary of important points that we've already learned. One is that the maximum volume of a square-based prism is a cube. So think of a box. If you want to get as much volume inside that box as you can, then you want it to be a cube. The formula for the surface area of a cube is surface area equals 6s squared because all the sides are the same. The formula for the volume of a cube is s cubed because that's length times width times height, but all three dimensions are the same in a cube. The maximum volume of a cylinder occurs when its height equals its diameter. We're going to need that point today. The volume for the surface area of a cylinder is SA equals 2 pi r squared plus 2 pi RH. And the surface area when you want maximum volume though is 6 pi r squared. The formula for the volume of a cylinder is, so this is all things that we have on our other notes elsewhere, but they're all important. Example 1. The designer wants to maximize the volume of a box that uses 700 centimeters square of cardboard to build. Find the dimensions to the nearest tenth. So he's got to use 700 square centimeters only of cardboard. That's what he's got. And he wants to get the most use out of that cardboard. He wants to maximize the volume of the box. He wants to get as much in the box that he can, so he can't just pick whatever dimensions are pleasing to the eye. He has to maximize. But look at this number here. So here's the word volume, but over here this is in squares, centimeters squared. That's not a volume number. We've got volume information here in the question that's important, but over here we've got a surface area number. So this is not a volume number, it's a surface area number. So what should we do? Let's think back to the points that I just read out. One of them is that the maximum volume of a square-based prism is a cube. So he's going to have to take this amount of cardboard and shape it into a cube if he wants to maximize his volume. It's going to have to be a cube. So the formula for the surface area, now why am I going to surface area? A second ago I was talking about volume. Why am I switching back and forth? Because the question is about both. It's about getting as much volume you can with this much material. So since we're given the surface area, it's important that we talk about the formula for the surface area. The formula for the surface area of a cube is SA equals 6s squared. Each side here, let me label them, each side here would be S, 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 right? All sides are equal because it's a cube. So let me just put these hash lines in here. They're all equal to each other because it's a cube. There's our formula. So what can I sub into the formula? What do I know that I can sub in? Well, this piece right here I'm going to sub in. 700 is 6s squared. So now I want to isolate s squared. So the first thing I need to do is divide by 6. Just show that in case you didn't know where I got that number from. Divide both sides by 6. Now I have to isolate s. I'm going to have to get rid of that power of 2. What do I need to do to both sides to get rid of the power of 2? So I can isolate s. I'm going to take the square root of both sides. That cancels out this square. This power of 2 is now canceled out with the radical, so with the square root. So we get 10.8. Now, what does that mean, that 10.8? 10.8 equals S. Remember what S is over here in our picture? There's our S. So if 10.8 is S, and let's make sure we're answering the question properly. The question said, find the dimensions to the nearest tenth. So now I can write a sentence, a therefore statement. Therefore, the dimensions are 10.8 centimeters by 10.8 centimeters by 10.8 centimeters. Dimensions always mean length, width, and height. Well, for a volume question like this, a three-dimensional question, length, width, and height. So you have to write it out 3 times. You can't just say dimension is 10.8. You have to write out all 3 because dimensions would refer back to length, width, and height. So we need to show a number for each one of them. So the calculation here is not very hard, but knowing how to figure out the question is, again, because we've got part of the question is about volume. We want to maximize the volume, but we're only given the surface area. So that's why we had to take our surface area formula to get the answer for the volume. So the volume would be 10.8 by 10.8 by 10.8. That, if we multiply all three of those together, we would get the volume for this question. It wasn't asking us for the volume, but if I multiply all those three numbers together, I get about 1,259.7. The question did say nearest tenth, so I'm just going to put 0.7 there. And that would be centimeters cubed. Question didn't ask for that, so that part that I just wrote in light blue is not needed. Question asked for the dimensions. So the volume, that's the biggest volume, that this light blue number here, this is the biggest volume you could possibly get given this much cardboard. That's the biggest volume you could get. Example 2. A cylinder has a surface area of 475 centimeters squared. Find the radius and height dimensions, which give the cylinder a maximum volume to the nearest hundredth. Okay, let's break down that question a little bit here. There's information about surface area. So we've got a cylinder and we know its surface area. This is the surface area of the cylinder. But we're looking for the maximum volume. Again, we've got a question with surface area and volume being intermixed together here. So what should we do? Well, if we're given the surface area, let's look through our summary points for something that will help us with either of these. Remember that the maximum volume of a cylinder occurs when its height equals its diameter. That's a really important point back from our first slide. When the height equals the diameter. So here's the height, and that's just the radius there, right? But the diameter would be all the way across. All the way across is the diameter. When the height and diameter are equal, if you can picture that, this one that's drawn here is not like that. The height looks bigger than the diameter, but when the height equals the diameter, you're going to get your maximum volume. So think of canned food you have at home. Can you think of any can of food where maybe the height is equal to the diameter? Maybe like a can of corn, that size is a little closer to that. So that's where you're getting as much as you can inside the can. So I'm using the surface area formula because the question, the part that I circled up there, is about the surface area. That's the surface area of a cylinder. But we've got a couple of unknowns in this one here. We've got an R, that's a variable right now, and we've got an H. Pi is not a variable, right? Pi is 3.14, so that's just a number. I could go ahead and do 2 times 3.14 if I wanted to get rid of the pi, but pi is writing that out is much better than putting the decimal in, because you can never write it out accurately. So we're going to leave it as pi. The height equals the diameter. Let's go back to that point here. If the height equals the diameter, so now I can go back and talk about these variables here. I had the R's and the H's. That's too many variables. It's going to be hard for me to solve that. So if the height equals the diameter, then instead of H, I could put D, because height equals diameter. And remember that diameter is the same as 2 radii. So I'm going to replace the H with a 2R. That's an important step there. So let me just collect those terms on the right side, and we get 4 pi r squared because we have an R times an R. That gives us the R squared. So I've got 2 pi r squared plus 4 pi r squared. Those are like terms. If I've got like terms, then I can add them together, and I get 6 pi r squared. So this is a formula, and this formula was on your front slide as well. But what I've just done for you, and you're going to do a lot more as you go through math, is you're going to come up with formulas yourself. So we haven't got any numbers or any calculations. You start with one formula and you come up with another formula. That's called deriving a formula. We don't do much of that all in grade 9, but you will later. So now you know where that formula comes from. That 6 pi r squared formula. That comes from the height being equal to 2 radii. So let's use that formula. surface area equals 6 pi r squared. Now I've totally lost what I'm doing. What am I doing here? Did all that work, came up with a new formula for surface area. Right, I'm told the surface area in the question, it's 475. Now I'm going to isolate r, so I'm going to divide both sides by 6, and then I'm going to divide both sides by pi. If you have a pi button on your calculator, that's what you're using here. You're not putting in 3.14. That is not pi. That is a horrific approximation of pi. Use your pi button, please. So 475 divided by 6, and then divided by pi, and we get, this is rounded, we get 25.1995 equals r squared. So that was, I'll put that in there. What I did here was I divided by 6 and pi. I divided by 6 and I divided by pi. How do we get r? Remember, we take the square root of both sides, square root here, square root here. These square root and radical power of 2 will cancel each other out. And we get about 5.02. And the question, look up at the top here, the question said nearest hundredth, so I need the 2 decimal places. After all that work, why did we do that again? The question said find the radius and height dimensions. So we've got the radius. Have we got the height? If the radius is 5.02, what's the height? What's the height equal to? How am I going to get that? Do I have to go back to this formula here and start subbing in and isolating? No, remember? The height is the same as 2 radii for this question. So my height is equal to 2r. And since my radius is 5.02, I'm just going to multiply those together to get the height, and then I can write a sentence that answers the question. Therefore, the radius will be 5.02 centimeters and the height will be 10.04 centimeters in order to maximize the volume. These therefore sentences are really important because they show your teacher that you know what you're doing. You're not just throwing a bunch of numbers into a formula, getting an answer, and then just saying r equals 5.02. Do you know what you found and why you found it? So it's really important part of the communication math that you can articulate the answer that you found, that you can explain yourself. When you do homework questions, if it's asking you a similar question like this about a cylinder, maximizing the volume of a cylinder, you don't have to do all of this work that I did. You can jump straight to this formula here. If you have a formula sheet, it won't have this on it, so you can memorize it if you want to. But anytime you have a cylinder and you have to maximize its volume and you're given a surface area, this is the surface area formula that you would use. So notice we're not finding the volume. The question didn't say find the volume here. It said find the dimensions. Just find the dimensions, which will give it the maximum volume. A lot of questions will have a third step, like a part B or C after this will say, what is the volume? And we haven't done that here, but that's how you find your dimensions. Then you would go back and look at your volume formula for a cylinder and you would sub in to get the maximum volume. That's the end of today's lesson, 13.5 minutes, pretty fast.